so we have a theorem which I mentioned earlier. And that theorem basically says that polynomials, rational functions, root functions, and trig functions, these are all continuous on their domains. So really what this means is a lot of continuity questions become domain questions. So if I say state the intervals over which this guy is continuous, what is that going to look like? Well, this basically becomes, what is the domain of this function, right? So this is really a domain question. So just as a reminder, there's two things that can happen with a domain. The first thing is you can have a 0 in the denominator. And the second thing is that you could have a negative under a even indexed root. Now, if you look at this function here, there is no radicals. So I don't have to worry about this second one. But I do have a 0 in the denominator, so I need to worry about that. So what I do is I set the denominator x squared plus 2x equal to 0, and I want to solve for x. So I got to factor this guy. This becomes x times x plus 2 equal to 0. That means that x cannot be equal to 0, and x cannot be equal to -2. So what we want to do is want to write this as an interval. So I can draw a little number line like this. Here's -2, here's 0. I'm going to have an open circle at -2 and open circle at 0. This part goes like this. And this part goes like that. So my interval is going to go from negative infinity to -2, union -2 to 0, union 0 to positive infinity. Does that make sense to everybody? All right. So let's take a look at example 9. This first example, we had a 0 in the denominator. In this second example, I hope you can see we have a square root here. The index is 2, because there's nothing written there, so we assume the index is 2. And this is when we have to worry about a negative under the even indexed root. Okay. So I'm going to solve this for you in 2 ways. The first thing I want to do is, I know that I want to take 9 minus x squared, and I want to see when that's going to be greater than or equal to 0. And how do I solve this? This is called we need to solve an inequality. This is an inequality like this. And what I'm going to do is I'm going to factor the left-hand side. So do you guys recognize anything interesting about this left-hand side here? Anything interesting? Not really.
It's a polynomial.
It's not just any polynomial, my friend.
It's a parabola.
I agree. If I told you it was a
Difference of squares.
Oh yeah, it's a difference of squares. Right. So then the benefit of seeing that is I can just factor it automatically, right? 3 squared is 9 and x squared is x squared. So this is just 3 minus 9, 3 plus 9. 3 minus x, 3 plus x. Greater than or equal to 0. Okay. So what we can do is we can check the values where this guy is going to be positive and negative. So I'm going to show you 2 ways to do this. One way to do it is the way that students really like a lot. So this way involves the following. I'm going to label a -3 over here, and I'm going to label a 3 over here. And we're going to use test points. So we're going to use test points. So my favorite test point in all the land is 0 because it's super easy to evaluate. So when I plug in a 0, over here, I'm going to get 3. When I plug in a 0 over here, I'm also going to get 3. So that's going to be a positive number. All I care about is the sign. I know that the sign is going to change at these 2 points. So just plug in a number in between. I can plug in a 4 on this side. When I plug in a 4, what am I going to get? If I plug in a 4 here, I'm going to get a negative number. If I plug in a 4 here, I get a positive number. And negative times a positive is negative. Minus. And then I can plug in a negative 4 over here. Plug in a negative 4, what do I get? This is going to be a positive number. This is going to be a negative number. Positive times negative is negative. So it's negative. You can just stick the number into your calculator to see if it's a positive or negative number. But if I do it this way, I hope you guys could see that the place where the domain is not negative is from -3 to 3. The question that remains is, do I want to include the endpoints? And the answer to that question is, what is the square root of 0? Well, the square root of 0 is 0, right? Because 0 squared is equal to 0. So that means having a 0 inside the square root is okay. So having a x equal to -3 and x equal to 3 is okay. So we're going to put square brackets around there. Does that make sense to everybody? Is there any questions? Let me draw a little line going down this way. Whoops. I'm going to do it a slightly different way. Okay, do it slightly differently. Stephanie, remember how just earlier I was talking about this is a domain question. We're trying to figure out which points we want to include, which x values we want to include. So what I was just saying is, it's okay to put a 3 in here because 9 minus 3 squared is equal to 0. So if you took the square root of 0, that's equal to 0. That's okay. So we want to include 3. That's why I put a square bracket for 3. Do you want to include -3? So we're going to put a negative in here. That's going to make this -3 squared minus. That's still equal to 0. Square root of 0 is still 0. We're okay. So we want to include both of these points. Does that make sense? So like for domain questions, you want to decide, are we including the endpoint or are we not including the endpoint? Because the square root of 9 minus 0 is equal to the square root of 9, that's equal to 3. So 0 is okay. Any point in between -3 to 3 is okay. Yeah. But you got to throw away all the points where you have a 0 in the, where you have a negative under the square root. All right. I was going to show you another way, but I'm worried I'm going to run out of time here.
Professor?
Yeah.
I have a question about how to write the, like, for example, at number 8, you write minus infinite 0.2. Is it the right way to write, or is it like minus infinite smaller than x, smaller equals to -2?
This is called interval notation. What you're talking about is inequality notation. So you need to be able to write both. But a lot of the homework asks you to write it like this.
Okay. Thank you, Professor.
You're welcome. I'm going to say there is another way to do this, but I'm going to leave it for now.